great. So my mom used to say that if you want people to listen to you, you have to speak to them after lunch, not before lunch. But I'll try to still get your attention. So just as a quick intro, I mean, yesterday in some of the talks, everyone was mentioning their Dr. J and Dr. J Frog. And I was trying to think, what doctor can I present myself as? And I'm not really a doctor. I used to play basketball professionally when I was younger, and I was trying to be Dr. J, but it didn't really work out. And then I switched to software, and I'm thinking maybe I'm going to be Dr. Java or Dr. JavaScript. Also didn't really work. But I'm one of the founders of Amplitude. And a little fun fact about myself that, like, no chance you will be able to guess, I'm actually the tallest speaker in this conference. But I've been in the software space for a long time now and working in different roles from development to product to testing to like a bunch of other areas. So I'll try to share some of my insights. And the agenda for today, so we'll start by going over some of the automation challenges that companies are facing nowadays. We'll look at some of the market trends and how these trends correlate to some of these challenges. And then we'll see how you can actually fix some of these challenges, and hopefully this will resonate well with the challenges that you guys are seeing. And I was told not to do Q&A, so if you have any questions, you can come see me at the booth later. And I know the animated GIF is unrelated to the slide, but someone told me that if you do a talk today, you have to have an animated GIF in the slides. So this box is checked, and you won't see me. So let's go over the automation challenges. So this is how a modern software delivery cycle looks like in most companies, like the continuous delivery. So it's not like the old waterfall where you have these like separate stages. Now everything happens continuously. You write the code, you test, you deploy, you monitor. It all happens all the time. And one of the keys in being successful with continuous delivery, by the way, I didn't mention, but I'm based in the Bay Area, and when you meet some of the startup companies, some of the tech companies in the Bay Area, everyone are doing continuous delivery over there. Everyone deploying hundreds of times every day, and it feels like, wow, the world is great, everyone are happy. But then when you go outside of the Silicon Valley and you go to some enterprises which have to deal with compliance and security and other aspects, it's much more difficult, and it's more difficult to get to that space. But one of the key things in order to be able to do continuous delivery is automation. You have to be able to automate your tests. You have to be able to automate your deployments. You have to be able to automate monitoring. And in order to automate, everything have to be reliable. Everything have to be very fast. And all these things are key. And we'll see some of the challenges that people are facing in getting there. Now, one of the things which a lot of vendors, we're also guilty in that, a lot of vendors are now speaking about this like great new world where like AI is writing the code, AI is testing everything. We don't really need all you guys, you can go home. But this is still very, very far away. So a lot of people are speaking about like autonomous testing and self-driving tests. And actually one of our engineers wrote a really fun blog post where he compared autonomous driving to autonomous testing. And if you know, like in autonomous driving, if you search in Wikipedia, they have this article explaining the 6 stages of autonomous driving. So the first one is like no automation. The second is like adaptive cruise control. And it goes on until like level 5, I think, which is fully autonomous. You don't even need a driver in the car. And even though some of the companies today are like in levels 3 and 4, I think, level 5 is still very far away. I mean, I think Elon Musk said it's just a few years away, but I have some friends working in that space, and getting from the 80% to the 100% in this case is very, very difficult. And in testing, I think it's a similar situation. I mean, there are some tools that are making great progress in adding more automation and more autonomy, but it's still very difficult. So with that introduction, let's look at the actual challenges and start going into it. So this is how a test automation workflow looks like in most companies. I mean, you basically start by making a product change. You execute the test. You first write tests to cover this feature. You execute the test. You analyze the test results. And then you start, if the test runs correct, that's fine. Analyze the results, report defects if needed. If the test didn't run well, you fix the test, and then you run the test again, analyze the results. If bugs were found, you have to analyze the bugs, find the root cause, and fix the bugs. And one of the biggest challenges is low test coverage. So companies are struggling to keep up with the coverage. New features, new apps are added almost every day or every week, and it's really difficult to keep up with the coverage. And one of the main reasons is that most of the time is actually spent in analyzing the test results and fixing the broken tests. especially when you run at scale and you have to cover multiple environments. This takes a tremendous amount of time. We recently did a research. Everyone published research results in the last few days, so I had to come with our own research as well. So we also recently did a survey, and we saw that like 40 to 70% of people's time is spent on analyzing the test results and fixing broken tests, and that's a huge amount of time, and it actually affects the ability to create new tests and add additional coverage. And when people speak about automated testing, in many cases, they're referring to UI testing, which is the most like widespread type of testing. And this tests the end-to-end functionality of the system through the UI. So it's not really testing the UI, it just tests the functionality through the UI. And a test is usually consisting of a set of actions which interact with the application under test and validate each step or each element or each aspect of the page. So it looks, something like you can see here. But there are some problems about it because a line of code, you have to add a line of code for each UI element. And if the UI changes, you have to maintain it. You have to maintain the elements. So it creates a situation where, like, for every part of the page, you have to add more code, more assertions, and it just adds up and adds more maintenance and creates a big challenge. And also, looking at the results, when you run all these automated tests with all these assertions that you add for each and every element, you have to analyze hundreds of lines of logs code. So it just becomes very difficult to scale this way. And if you do multiple releases per day, every time you have to run the test, there's some failures, you have to analyze the results, it becomes a pretty big challenge. So the first challenge, as we discussed, it's the low test coverage. Basically, every assertion increases the matrix, the maintenance overhead. You start asking the question, is it really worth automating for every new feature, every new aspect that you add? And it checks basically the system functionality through the UI. Usually it doesn't check the UI itself. We'll speak about it a bit later. And the other thing, it can only catch expected bugs. This is like, there was a famous talk in the Google Test Automation Conference a few years ago where one of the Google engineers told a story about a flying unicorn that was presented on the screen in admin mode, and they didn't really have a test to check that there is no flying pony on the screen, and then accidentally it was pushed to production, and a flying pony was on the screens in the production. So again, the automated tests, the way they're typically written today, are only looking for expected things, and the result is you still need manual testing, and when you need a lot of manual testing, it affects the ability to move to continuous delivery. So that's the first challenge. The second challenge is the slow feedback. So because of the first challenge and because analyzing test results and fixing broken tests takes time, by the time you get to actually analyze the results and find the defects and report the defects, the developer who wrote the code, again, it might be the same person, but the developer who wrote the code might move to his next task, and then when he gets the bug, you have to do the context switching and try to remember what he changed and try to find the area in the code that changed. So this also takes a lot of time, and the slow feedback loop is actually causing some delays as well. And this also affects the ability to do root cause analysis. So when you get the defect, finding the root cause of the defect is hard. And another challenge which is really, really difficult, and we'll speak a lot about it later, is the ineffective and slow cross-environment tests. So over the last few years, a lot of people have been pushing to test everything on the same devices and the same browsers that your customers are using, which is generally a good advice, but people have started doing too much of this. When you take every test, you try to run it on all the browser and all the devices. So not just you have tests with some level of flakiness. Let's say that some of your tests have 2% failure rate because of environment flakiness or other reasons. Now you take this 2%, if you had like 10 tests, now you run these 10 tests 10 times, so it just adds up and you have more failures and you spend more time analyzing and more time fixing maintenance issues. So it prolongs the execution, it prolongs the results analysis, and it also requires a very expensive lab. You have to spin all devices and browsers. And when you ask the question of like, what bugs are we actually trying to find, most of the server bugs, like the functionality bugs, are environment agnostic. It doesn't matter if you run it on Chrome or Firefox. If the DB query failed, it doesn't really make a difference. And even the application-specific bugs or browser-specific bugs are rarely on the functional side. They're mostly on like the visual side. So this is a challenge. We're going to speak about it later a lot on how it can be fixed and how a lot of companies are addressing it now. And the last challenge is lack of skills and experience and also access to talent. And again, we're also going to speak about that. But a lot of companies, finding people with the right DevOps skills, with the right automation skills, that's a rare resource. And again, there are some areas where more talent is available, but most companies are struggling to hire people fast enough with these types of skills. So that's a big challenge that is slowing people down. So now that we understand these challenges, let's look at some of the market trends and also cover some statistics. Just the lights are blinding me, so I'll try to stand here. So we'll try to cover some relevant statistics, which I hope you will find interesting. So again, everyone we're doing surveys and results, I had to come up with a few slides to show some statistics. This is not based on 5,000 companies like Shlomi from yesterday. This is only 400 companies, but hopefully it will be relevant. So the first question was like, what top trends or what top initiatives companies are going through right now? And it's interesting to see that like a big chunk, like 60% of the people are already like in the CI/CD phase, or like at least trying to get into CI/CD. I hate the word digital transformation, sorry about it, but like 51% of the people saying they're like undergoing digital transformation. AI is starting to kick in as an initiative, shift left, shift right. Again, we'll skip that. And the other thing, a lot of companies are still in various stages of partial automation. So, you go to some conferences, you hear a lot of people say, yeah, we're 100% automated. But when you go and check the reality, a lot of people are still, like 50% of the people are still like lower than 50% automation coverage. And when you look into visual testing, like checking the visual, the digital experience, all these areas, the results are even lower. So 50% still do it manually or not do it at all. And probably skip this slide with digital transformation again. But digital transformation is accelerating rapidly. So companies have more apps to test, more pages to test. And this just makes things really hard. It's hard to keep up with the coverage. It's hard to keep the stability. It's hard to keep the scale. So let's go over some of the trends and see how these trends relate to the challenges and how they can help us fix some of the challenges. So the first trend that like everyone is speaking about is AI-assisted testing. People speak about reducing the test maintenance overhead with AI. There is this concept of self-healing tests. I mean, one of the challenges with automation, when you run the test, if the application changes, you have to redetect or relocate the elements by the new locator or the new selector. So there are more and more tools, open source and commercial, that allow you to do this self-healing. I mean, they know to automatically detect multiple ways to locate the element. And if the element changes, it knows to fall back and still be able to find the element so the test doesn't break. Timing anomalies, this is also something that a lot of tools are now supporting. So when you run the test, it knows how much time each action took last time you ran it. Like if things are slower now, if things are not loading correctly, this detects it automatically. It reduces some of your need to do that. And also doing smart crawlers. So like instead of writing tests to check everything, the test will know to crawl the application and get through some of the things. Another big trend is codeless testing. So codeless testing used to be, or like record and playback used to be not cool. I mean, if you would go to a conference 2 years ago and say you're doing codeless testing, everyone would say like, who is this idiot? But today it's actually starting to re-evolve. And I think one of the reasons for that is the tools are actually making a big progress, the commercial tools as well as the open source tools. And Selenium IDE, which was one of the tools that was supporting record and playback, actually reached end of life about 1 year ago because of some changes that Firefox did. And we actually decided, we as ApplyTools decided to take over this project, not take over, but like support this project and contribute a development team to help bring it back to life. And it was actually now released again. It's still fully open source, but it allows you to do record and playback in a very reliable way with the self-healing capabilities and all that stuff. So I strongly encourage you to look into this project, Selenium IDE. It's becoming a really cool tool, and it's continue to evolve. So I think it's pretty cool. If you have time, maybe we'll also see some demos for that. Another big trend, which I'm sure you're all seeing, is like more developers are now writing tests. And there is a need for speed. You have to test quickly. The tests have to run fast. You have to get the feedback quicker. And there is no more release. I mean, you used to have like a deadline to release in like 1 month, and everyone was like looking after this release and checking it and doing acceptance testing. But now the idea is like the code has to be ready to be released at any point in time. Like every time you change the code, it has to like be fully tested and ready to be released at the point that you're deciding to deploy it. And also, like the thing about throwing things over the wall, I mean, it used to be, okay, I'm the developer, I'm building the code. There are actually a few versions of these slides over the last 2 days that people presented, so I think you get it. But This is also like no longer relevant. And also the QA gateway, I mean, it used to be, okay, let's send it to QA and they decide if we can ship it and do all the checkbox. I think now everyone shares this responsibility and the developers can make decisions and they have the authority to deploy. So everything has to be automated and fast and quick. And basically the conclusion of everyone now is that developers must test. I mean, you have to expect the developers to test, and test has to be part of the development cycle. It can't be like a separate stage that happens at the end of development. Tests have to run all the time, and the tests have to be fast. I mean, developers shouldn't wait for the results for a long time. They have to commit immediately. I mean, it just have to run. Everything has to be immediate, and you need to know that the code runs when you will deploy to production. So developers actually started writing tests, and I'm seeing it in more and more companies, and it's actually working pretty well for companies that are doing it. Again, I won't mention names of companies, but there are a few companies that started this transition a few years ago, and I'm seeing some pretty good success in companies where there is still quality engineers, and they're still helping with defining the quality standards and defining the tooling and building the frameworks, but developers get the responsibility to test new feature. They need to build the coverage, and it works, at least from what I'm seeing, it works very well. And there are two main schools of thinking when speaking about testing for developers. There is the pyramid school. You've probably seen it before. You have a lot of unit tests at the bottom, which are based on some mocking and other stuff to test each and every unit in separation. Then and the idea here, unit testing are very fast and easy to write, so you do a lot of these unit testing. Then you have some integration testing in the middle, and you have few end-to-end tests because these are the most expensive and the most or the slowest test. And then there is the diamond school, which more and more people are speaking about now, where basically you have some end-to-end tests at the top, you have a lot of integration tests, and you have a few unit tests. And again, the reasoning behind the diamond school is in the past when the pyramid was defined, integration testing were very hard to write, it was very slow. Now there are some modern tools that allow you to do integration testing in a very effective way, and there is no need to spend too much time on unit testing, building mockups in order to test each unit independently. You can actually do integration testing where you check multiple units together in the same way as they're actually going to run in production, and it can still be done in a very fast way. There are cool tools like open source tools like JS DOM, which more and more companies are doing, which are really helping here, and still do end-to-end tests when appropriate. And everyone are asking which one is better. I don't really want to take side here because immediately half of the audience will start hating me. So I'm just going to say both are cool as long as people test. And there are some commonalities. I mean, these are the important commonalities between these two approaches. The first one is the need for speed. So everything has to be fast. You have to have fewer end-to-end tests. This both methods agree about it. And currently, when people speak about the pyramid or the diamond, they usually refer to functionality testing only. And there are some other types of tests like visuals and others which can actually help here, which we're going to touch about later on. So, and by the way, I keep seeing the timer here counting how much time left, and I'm thinking, okay, they're probably counting the time until lunch, so I want to switch it around so you can see, but it's 28 more minutes, but I'll try to make it quick. I want to hold you here for 28 more minutes. So developers finally have a somewhat common methodology when it comes to testing. And there's some few cool tweets that are included here. By the way, if you don't follow these guys, I strongly encourage. So write tests, not too many, mostly integration. And actually, this guy is really awesome. His name is Kent C. Dodds. And he coined the term the trophy of testing, where basically, again, it's kind of similar to the diamond, but do some unit testing, a lot of integration testing, and then some end-to-end. But also at the bottom, you have the static analysis, the linting, all that stuff, which also helps. And another big trend is that cross-browser testing is actually starting to decline. I mean, again, 2 years ago, everyone was speaking about cross-browser testing and how important it is to run all the tests on all the environments and all the browsers. And there are basically, when you think about why it's declining, practically there are three main browsers out there today: Chrome, Firefox, and Safari. And when you look at mobile, even less, only Chrome and Safari are pretty much relevant. And I see everyone are nervous, where is IE and where is Edge? So IE is mostly dead. I mean, again, in the enterprise, it's probably, sorry if I insult anyone, but in the enterprise, it's probably still relevant, so you can't ignore it. I realize that. But I expect that in a few years, it will be gone. And the Edge team actually announced that they'll move to Chromium in 2019, or in about a year. So Edge will practically become the same as Chrome. So it reduces a lot of the need for cross-browser testing. And when you think about it, for most of the applications, browsers are functionally the same. So what are the chances that you click on a button on Chrome and it clicks on Chrome, and then you try to click the same button on Firefox and it won't click on Firefox? As long as you develop, by the standards, and as long as the browser vendors are doing a good job testing the browsers, which they usually do. I know the test teams in most of these browser vendors, and they're doing some great, they're doing an awesome job. So the application, it's practically the same from a functionality perspective. And finding browser-specific bugs is becoming really rare. It's difficult to find these types of bugs, but the time and money you need to spend to actually test it is not getting cheaper. It's still expensive to spin up a lab. It's still expensive to run each test 10 times, so it's not necessarily the right way to go. And the only exception in this case is visual bugs. So the difference between browsers are still in the rendering engine, so Chrome and Firefox and IE and Safari still have different rendering engines, so things might render differently. Especially, you also have this complexity of the viewport sizes for responsive website and the pixel density or the pixel ratio. So there is still, this is the area where we're still seeing a lot of inconsistencies, and there's still a lot of bugs which are causing issues. So we pretty much covered the relevant trends in the market, and now let's see how these trends can relate to some potential solutions to the problems that we discussed. So one of the areas which was overlooked for the last few years, but is starting to get more momentum, is the idea of visual testing. And visual testing is basically the idea of testing the look and feel, the digital experience of the application on all the different environments, and covering fonts and colors and the position of the element and the actual text and content itself on all these different environments on top of your functional tests. And visual testing helps you find issues that are not currently covered by typical functional testing tools. Like you can see this example from the UPS iPad application. On certain iPad sizes, the store information is cut, and you can't really see the buttons, you can't really see the text. So a functional test will actually pass in that situation. You can click the button, the text is in the DOM, but from a visual experience perspective, the experience to the user is broken. And again, there are other examples from Twitter and even from Amazon. When Amazon had Prime Day, I think it was 1 or 2 years ago, there were a few hours during the day where some CSS files were not loading because of the load on the server. And from a functionality perspective, everything was working. All the functional tests, all the monitoring scripts were working fine. But the users, the users could complete a transaction, but no one would purchase anything from a site that looked like that. And they only realized it when they started seeing the drop in transaction. So these are the kind of things where visual testing can help you. And if we go back to the challenges, so the first two challenges we spoke about were low test coverage and slow feedback. So let's see how visual testing can help with addressing some of these challenges. So if you remember the screen here, like you have a website with a lot of UI, and you have to add code to validate each and every element. One of the nice things about the concept of visual testing is that you can validate every screen with like one individual assertion. So when you check the page, it checks everything on the page. You can exclude certain elements, but it basically checks everything. So you just add one line of code, and it covers everything instead of asserting each and every element. And the challenge with this concept has been like of the visual testing was, how do you deal with false positives? Okay, so you take the full page screen, that's great, but then you run it again and the test runs on another machine in the lab and it just renders slightly differently. So you start dealing with false positives, or Chrome comes up with a new version, and in the new version of Chrome, there is a new rendering engine, so it renders the pixels differently, and now you have to recheck everything and reapprove everything. So these challenges made it pretty much not really practical. And companies who try to do visual testing abandoned it at some point just because it didn't work and it created a lot of overhead. So the modern tools today actually get to a very high level of accuracy and eliminate this factor of false positive. And the other, missing a slide here? Okay. The other big challenge with visual testing was the maintenance overhead. So you would run a test, you would check multiple screens in your application, you would check it on different browsers and different screen sizes, but you make changes to the application all the time. You add buttons, you add features, you change colors, you do rebranding, whatever, and this adds up an overhead. So every time you make a change, you have to look at it in all the screens and approve it like multiple times. This added a lot of overhead. Again, now tools support what is referred to as automated maintenance, so you only need to approve a change once. You don't need to approve the same changes over and over again. It allows you to move fast. It reduces the need to maintain multiple tests. And okay, so The slides got messed up a little bit. But so basically the idea, the challenges of low test coverage and slow feedback are pretty much solved now with these modern tools because it gives you visual and functional coverage. Everyone in the team can actually contribute to the test results analysis and to writing tests. It's not like looking at hundreds of lines of logs. You can actually look at the screens that change, and everyone can understand this language and see the changes and accept changes. And this concept of automating the maintenance actually allows you to scale and making it very easy to review the test results. Now, we spoke about the challenge of analyzing the root cause of the issues, and one of the problems here, either in a regular test where you just see, like the logs in a text file, or, like just put it to Jira, or in a visual test where you see some highlights of the areas that were changed or that are affected, is okay, so you run the test, you found this issue, okay, something changed here, you can see it side by side, put it to Jira. By the time it gets to the developer, he needs to now remember, okay, when did I make this change? Maybe revert back to the code to this version and do the code diffing and all that stuff. So it takes a lot of time and it's a huge overhead. There is a new concept of like root cause analysis where basically whenever a difference is found, you can click that difference and it will take you back to the code and you'll be able to see the changes in a like GitHub style view and immediately correlate between visual differences and code changes, so it makes the whole root cause analysis issue much easier. Yeah, more animated GIF. Another challenge we spoke about is ineffective and slow cross-environment tests. So I want to speak a little bit about how this is done today in most companies and some of the challenges around doing it this way and the new concept which I'm starting to see people implement to address this problem. So this is how test code looks like today for the most part. I mean, you navigate to a page, click some buttons, check the screen, make sure it looks right, and again, do the same, move to another window, check the screen. And it looks simple, but it's not that simple because you have to run it on different browsers and devices. You have to deal, again, with pixel ratios and sizes. So you end up running this same test multiple times, and it adds overhead, it adds flakiness. And you take it on Chrome on one size and Chrome on a different size, and Firefox, you just repeat the same test code exactly, and you run it 10 times. But from a functionality perspective, we spoke about it already. There is not much difference between the different browsers, so it's pretty much a wasted effort in many cases. So, you ask the question, do you really want to run the test 10 times on every environment? It's not really a good idea. And even when you have modern tools, so there is, I'm not sure how many of you are using Cypress, but Cypress is a new open source tool that came up kind of like as an alternative to Selenium or like an addition to Selenium, depends on how you look at it. But Cypress is a really cool tool. It's open source, it's faster, and it's, some people say, easier to maintain also. But even with Cypress, like running the same test 10 times won't get you far. And again, people try different solutions like parallelizing. So again, you take the test, you run it 10 times, but you run it in parallel, so the performance or like the speed factor is not, or penalty is not that significant, but you still deal with the maintenance overhead. I mean, you run the test 10 times, you still have some percentage of flakiness. Now it's just 10x more flakiness. So parallelizing the test is not necessarily the right solution, and there is a better solution. And the better solution is to actually parallelize only the screenshot part. So if you remember, we spoke about, browsers are pretty much functionally the same, so you don't really need to test the functionality on all these environments. You can actually parallelize only the part of comparing the screenshots. So you can run the test only once. You can see like only one test here. And every time you get to a check screenshot step, just check the screenshot on all these environments. And how you can do it, you can actually, and by the way, like we also like implemented this, and it shows like amazing results. You take the DOM snapshots, the CSS files, the images, like everything that the browser needs to render the page locally on the local browser, and you send that to a grid that renders these images concurrently on Chrome and Firefox and IE on different screen sizes. So the functional test runs once. You check the functionality only one time on one environment, so all the flakiness that you have to deal with, only one, but the visual validation runs on all the other environments, so you still deal with the chances of having the visual differences between all the different browsers. By the way, 16 more minutes, bear with me. No, but again, I think we're getting to the end, so we'll try not to take the whole 16 minutes. And the idea is like at the end, Visual Grid will produce the screenshots, and these screenshots will be sent to an image processing engine of some sort. Again, I'm from Applitools, so I included the Applitools logo, but there are many other solutions, open source and commercial, that you can use for that. And this pretty much solves the challenge of ineffective and slow cross-environment testing. I mean, you cover all the environments at the speed of running one single test. You still find visual bugs that are environment-specific, and it's at the fraction of the cost and speed of like spinning a fully functional grid or a device farm. Okay, so you might ask, how does it look like? Show me the code. So let's try to look at the code. I mean, the internet is really slow here, so hopefully the demo will work. But I'll try and see. Just bear with me for a second. So, so for this example, I basically picked a test in Cypress, and in this case, I'm just running the test just on one environment, on iPhone 10, and it's a test that just navigates to a page, does some actions, then check the window. Check window basically takes the screenshots and check it, then does some more actions to interact with the page, and then check the window again, and again, does some more actions and check the window. So I'm just checking 3 windows. I use the To-Do MVC demo application, which you might be familiar with. A lot of front-end developers are using it for demos of front-end stuff. And again, this test is written in Cypress, so let's just open Cypress to run the test. So that's the Cypress UI, and I think this is the test I need to run. So let's just run this test. It will open Chrome, and it will start interacting with the application under test, putting some slower than it's supposed to. Okay. Not connected to the internet. Yeah, so I guess the connection doesn't really cooperate with me. But basically, the idea is like when you run this test, the test just navigates, clicks on every window, and every time it calls this check window, it validates everything on the page. And then if you go to the dashboard to see the results, you can see, let's just switch to the other window. You can see like all the windows that were tested and everything that was approved, and you can run it on one environment, and you can run it on 10 different environments. I'll just tell you what I was supposed to do in the demo if the internet was working properly. So you can, instead of running it on one environment, you can run it on 10 environments, and then when you run it on 10 environments, it will just run at the same speed as running on a single environment, so it just makes everything run much quicker. So after this amazing demo that was working so nice, let's go back to the slides. I might try to make it work again better. So one more thing, remember the one more thing from the Apple presentations, actually 2 more things. So if you remember, the last challenge that we spoke about was like access to talent and training resources and making people know how to do testing correctly. And actually, these are 2 topics that I'm really passionate about, and we also, as a company in Applitools, think it's really important. So I wanted to share with you 2 key initiatives that we're working on in order to try to solve these problems. The first one is the Applitools Test Automation University. So we actually launched it, we call it TAU. So we launched it in January 1st, which is less than 3 months ago. And there is already 11,000 people around the world which completed trainings and courses. And there is many different courses about unit testing and API testing and monitoring and CI and a bunch of other topics by some of the leading speakers and thought leaders in the industry that are teaching these courses. So I strongly encourage you to look into it and register and take courses. It's completely free. That's just as a way to get more people into automation and get people to do it right and be successful. And the second initiative, which is also really important, one of the previous speakers also spoke about diversity and getting more women into tech, so we're also passionate about this, and we decided to tie 2 initiatives. One of the initiatives, we wanted more and more open source projects to be able to visually test. Our solution, Applitools, is automated visual testing, so we decided that all the open source projects will be able to use it for free so that we can get adoption, we can get feedback from some of the top projects. And when you look at open source projects are powering some of the coolest new initiatives that are out there. So we were thinking if all the open source projects will use it, we'll get a lot of feedback, we'll be able to always stay ahead of the curve. But open source projects are maintained by people who also usually have a day job and they have other things to do, and it takes them a lot of time to even do just add additional features or fix bugs. So we actually decided to start a program where we identify women that would like to get into tech, and we assign a mentor to work with them on adding visual tests to open source projects that are interested, and this way we add coverage to these open source projects, and we also help these women get into programming and learn test automation and learn front-end development, and we just sponsor it because we think it's important. So if you're part of an open source project, you're welcome to ping us, and we'll be happy to give you access, and also happy to get apprentice to build the code for this project. And if you're a woman that is trying to get into programming, also feel free to ping us. We'd love to give you the mentoring and sponsor your work on these types of projects. So again, these two, I expect great benefits out of it. I mean, the Test Automation University, as I mentioned, we're hoping to get more and more people to take courses and learn, and we're trying to add a new course every 2 weeks. So I think now we have about 10 courses over there, and we'll just keep adding more and more, so it will add additional topics and try to cover everything that is relevant. And open source projects, again, we get more and more projects running with Applitools almost every week now. So this is also cool. We get a lot of feedback, and we try to bring some value to the community. That's it. With that, I would like to thank you. My Twitter handle is Moshe Milman. I'm here in Melbourne for another 24 hours, so if you have any tips about good restaurants and bars, please tweet me and let me know. And thank you very much for taking the time. I really appreciate your time.